Hi guys, welcome back to my channel. So in this video, we'll see how we can detect faces using OpenCV. First, we'll see how to use the webcam using OpenCV in Python. Then we'll see how to implement Haar featured cascaded classifier in detecting the faces. So this video is made keeping beginners in mind. So you will get the links for all the code, the Python code which we'll be using in this video, and also for the classifier, the pre-trained classifiers from OpenCV. So watch the entire video and let's get started. So before we directly jump into the face detection part of the code, let's try to start from the basic, that is accessing the webcam. Okay, using OpenCV. So here I'm using Spider IDE, which you can see over here. So this is actually available in Anaconda Navigator. Let's begin with the code. So as I already told you that this video is using OpenCV. So the first thing is we need to import OpenCV2. Okay, that is the OpenCV library. So after you have imported, you need to create an object webcam, wherein we'll be using a class called video capture. It's actually V capital video capture class from the CV2 library. Okay, so video capture needs an argument to be passed, that is 0. 0 is nothing but the inbuilt webcam in your laptop. Okay, so the next thing is creating an infinite while loop. Why are we creating an infinite while loop? Is because we need to keep reading the frames captured from the video. Okay, each and every frame captured from the video. So how do we create the infinite while loop? I'll be using infinite loop. I'll be using while while true. Okay, so while true, what I want to do after you go inside the infinite loop is I want to read the video which is captured, that is a frame which is captured, right? So from this object. So how do we do it? So I will say you have to return me a boolean value from the read function and store it in a variable called frame. So what I'm doing here is, as I told you, webcam dot read. Okay, so read function actually returns a boolean value. Okay, meaning that indicates whether the frame is captured successfully or not. Once the read function is successfully done and that frame is captured and stored in the variable frame. So after you capture the frame, what do you need to do? I need to show it in a window. So I'll be using cv2.im show function, so which actually shows in a window. Okay, so the first thing, as you can see, it says that we need to pass 2 arguments to it. So the first argument is what is the name of the window you want to keep. Let me say as webcam output. Okay, so this is the name of the window which will open. Okay, so what I want to show in this window, I want to show the frame, the variable frame. Okay, so once we have now actually output, we are sending the frame output to a window. So now as I told you, this is an infinite loop. We need to stop the program in case if we want to. So how do we stop it? I'll be using by a keyboard interrupt. Okay, so how? I'll be using a if loop over here. If cv2.wait key function, it waits for the key input from the user. Let's say it requires an argument that is seconds. It waits for 1 millisecond. I'll say 1 milliseconds. Okay, and I'll be using an AND operation. I will be explaining you why I am using this and further. So if the key input, that is this complete value, is equal to odd, and I'll say it as if I press D, I need to interrupt, I need to stop the program. Okay, so I'll be explaining you why this is used. Okay, but on the like very simple ways, if this value is equal to this value, then what you need to enter the if loop. What you need to do, you need to break the while loop. So it will break the while loop and come out of the while loop, and what I need to do is I need to release the webcam. So that means I need to disconnect the webcam from our OpenCV project. Okay, I'll say release. Okay, then after release the webcam, what I need to do, I need to exit, I need to destroy all the OpenCV related windows. Okay, I'll say destroy all windows. Yes. Okay, so this is a very simple code, guys. So let me just run this and show you if it works. Hopefully it works. I just run it and it's running. It opened a window. As you can see, a web camera output is the name of the window which we actually used over here. So let's say if I press some other key other than D, it doesn't stop the program. So let me just press D. Yes, it exits the program. It terminates all the windows and exits the program. Okay, so this is a very simple code, guys. So now let me just explain you what is this. Okay, yeah. So you can see this is nothing but this value, that is ff, is nothing but the 255 integer value. So 255 in 32-bit integer, in binary it is represented as this. Okay, very simple. So binary of 255 in 32-bit integer, the integer is represented like this. Okay, so so now we know that what is CV2 key input. So this is this gives output which is 32-bit integer value, that is a key pressed. Okay, so now we are multiplying this one with this one. Why are we doing this? Because we need to make the first 24-bit to 0 value. That is, we need to, the value which is coming out of this, that is a 32-bit integer, the first 24 bit, okay, except the last 8-bit, we need to make it 0. Okay, how do we do it? So we know that this value is nothing but 24 zeros and 24 zeros, and last 8-bit is set to 1. Okay, and then we are doing an AND operation, that is this, between the value which is output from the CV2 key, that is a key pressed. Okay, let's take an example. So this is the value which is coming out of the keyboard, which cannot be, because we have some value over here and our keyboard can only output 0 to 255. Okay, because we have very limited number of characters. Okay, so let's say we have got some value like this. So we are only comparing the last 8-bit value, correct now, last 8-bit value with our designated key. Okay, last 8-bit value of the value. So now we need to make the first 24 zeros. So that is why we are multiplying this with this. So why are we doing AND operation? We know that anything multiplied to 0 is always 0, but when you multiply 1 to 1, that is when it remains same. So this is same value as this one, but when we are multiplying 0, all the first is set to 0. Okay, hope I guess this is very clear. So now what we are doing, so we have multiplied these two. Okay, and this is the output value of this one. So now we will be comparing this one with the odd value. Is this value equal to this value? If that is equal, then it will enter the if loop. Okay, so what is the D value? D value is nothing but 100 in Unicode value, if I'm not wrong. Okay, so what is this D character? We need to convert this D character to Unicode value. So that is why we are using odd function. Hope this is very clear. We are using this function as a masking of first 24-bit values to 0. And as we are only focusing on the last 8-bit. So before we start with the face detection part, that is the coding part, we need to understand few concepts. There are multiple ways to perform face detection. The basic, that is using OpenCV, but OpenCV is no more in development. But still, the algorithms which we'll be using today are still being used in many computer vision industries. So you might have observed in your smartphones that when you're taking a photograph, so it detects the face. So it is somewhat similar, but they might be using a different algorithm, but this algorithm does the same. So how does this algorithm, how is the face detected In this, we use something known as classifiers, where the algorithm detects whether the input image to this model has a face or not. So how do we create or build or use such algorithms? So these classifier algorithm has to be trained on thousands of images with faces and without faces. That is, we train this algorithm with the image with a set of thousands of images which contains face, and we also train the algorithm with another set of images which does not contain faces. So we need not worry about or training a new model with thousands of images. But because OpenCV has already pre-trained face detection classifiers which can be readily used. One of that is the frontal face underscore default XML, which you can see over here. So to start with the face detection code, we'll be starting with the same code what we used for running the webcam. So before you start programming, you have to download the pre-trained model, that is Haar cascade frontal face default. This can be downloaded from the link mentioned in the description, that is the GitHub page of OpenCV. And then if you want the Python code and also the pre-trained model, you can just go to the blog, a Tasty Tech Harbor blog, where you can download the code and also the XML, that is a pre-trained model. So once you have downloaded the XML model, so you can start creating object. Let's say I will say it as face underscore cascade, and then you use cv2 method dot you will have to use the cascade classifier function, that is, sorry, the class. This is the cascade classifier class, and then it needs the XML file, that is a pre-trained model, as an argument. So let me just copy the name of the file and put it in the quotes. This has to be put in the quotes. So now we have the we have loaded the model into our Python code. So the next thing is, after all the code, all the processing of this comes in between showing the frame and reading the frame. So this is where the magic happens actually. So let's say here I will have to now create a variable called gray. As we all know that this model requires grayscale images or grayscale video frames. Okay, so I need to convert this frame which is in the color format to grayscale. So how do I do that? So I have created a gray. So I'll say cv2 dot cvt color, and this is the function which I'll be using. And the first one is a source. The source is nothing but the image, that is the frame. And the second thing is what do you want convert it to, that is cv2 dot color underscore bgr. Bgr is the format how the open cv reads the image, that is blue, green, red, and you want to convert it to gray. So this is the function which I'll be using. Okay, so then next, if you want to see this gray image also, you can say cv2 dot cv2 dot I am show. Okay, and what do you want to show? You want to name the window as gray video, and what do you want to show in that video is the gray frames. Okay, so the next thing what you need to do is, we have got the frames, so you need to pass this gray image to the classifier, and you need to store the output from the classifier into a variable. So what we'll do is, we'll create faces as one variable. Okay, is equal to, and is equal to face underscore cascade dot detect multiscale. So this is the function which we'll be using to pass the frame to the classifier. and to get the output from the classifier. So what are we passing? We are passing gray. Okay, and what is the second? It's the scale factor. I'll be explaining you about this further. Then I'll be giving the minimum number of neighbors. So let's say I'll say 5. Okay, so I'll be telling about this further. Okay, so now we have got faces is nothing but the tuple, that is kind of an array. Okay, so what the array outputs is the coordinates of the place where the face starts, and with the width and height of the face. Say for x comma y comma w comma h. So this is the value in faces which we are getting from the output. Then now I will have to draw the rectangle. So what I need to pass to the rectangle? So rectangle needs, where you want the rectangle to be present? I want it to be on the frame. And what is the coordinates? First point coordinates, that is x comma y. What is the second point coordinates? That is x plus width comma y plus width, y plus height, sorry, height. Okay, so the next thing is the color. So what is the color you want? Let me say 255 comma 240, that is somewhat yellow color. Okay, and then comma, what is the thickness of the rectangle? That is 2. Okay, so now let me just run this program and see how it works. Yeah, so it is running over here. So this is the color image. You can see my face is being detected. And if you want to see the grayscale, so this is the grayscale window. You can see I have named it as gray window and the web camera output. So let me just exit it. Yeah, so this is a very simple code, guys. And also there are a lot of pre-trained models which you can build, like detecting the eyes. There is a lot other, detecting smile, detecting upper body, lower body. So this is all the pre-trained models which you can use for your projects. So talking about the two parameters, that is a scalar factor and minimum neighbors, which you are passing to detect multi-scale function. So the scalar factor is nothing but a specific value by how much the image size is reduced at each scale, image scale. Suppose the scale value is, let's say it is set to 1.03, it means we are using small step for resizing. That is like we are resizing just by 3%, which can be a good accuracy, but might take time. So this is like a trade-off between detection accuracy and speed. If the scalar factor is too large, let's say it is set to 2, there will be a fewer steps, but the detection might be faster also, but you might be losing on detection of objects. So for example, like whose size is in between the two tested scales. So let me just demonstrate you what happens. Let me set the value to high. Okay, let's say it is set to 2. Let's run the object. Yeah, so you can see the detection is not so good. Okay, detection is not that great compared to our 1.1 value. So let me just decrease the scalar factor 1.1. So you can see now, yeah, the detection is really good. Okay, so this is about the scalar factor. Coming to the next parameters is minimum neighbor. So minimum neighbors is like it's a specific value. It is a number which determines how many neighbors like the candidate rectangle should have to retain it. So this parameter will affect the quality of the detection. The higher the values result in less detection, but with a higher quality. Let's say I set it to 7. That means that the quality is increased, but might cause like less detection. So if I set it to, if I start, so the quality is good as of now. There is no problem, but sometimes it might not detect. Okay, so but usually the recommended value is somewhere between 3 to 6. So I'll keep it to 5. Okay, let me just show you keeping it to 0 what happens. So we are saying that the neighbors, the number of the rectangles in the neighbors is 0. Like in that case, let me just run this. So you can see a lot of detections. So multiple detection is being detected. If I say 3, so you can see, yeah, even 3 is also good. But let me keep it to 5, which was our value. Thank you for watching. Hope this video was helpful. Link to all the resources is mentioned in the description below. And also check out my blog tastytechharbor.com for more related topics. And there are a lot of upcoming tutorials and the projects coming up. So subscribe to my channel, hit the bell icon, and to get notified. So thank you again. Take care. See you in the next one. Bye bye.